Yeah, guys. Today we'll discuss here exterior gateway protocol, EGP. So earlier we have like IGP as well as EGP routing protocols. IGP stands for interior gateway protocols. In that we have dynamic routing protocols. Those are the RIP, eAGRP, OSPF. Apart from that, ISAs. These all are the dynamic routing protocols. Apart from that, these all are the IGP protocols. And dynamically we should have to configure, but here today we are discussing here that is BGP protocol. And the BGP stands for border gateway protocol. Give me a second. Yeah, BGP stands for border gateway protocol. And BGP is a one of the open standard protocol. It's a border gateway protocol, and it's open standard protocol. Open standard, it means
Both Cisco and non-Cisco proprietary.
yes, we can use this protocol as a in Cisco devices as well as in non-Cisco devices. Both we can use for this BGP protocol in Cisco also, and in non-Cisco also we can use this protocol. Non-Cisco devices, routers, switches, wherever if we want, we can use this protocol. And BGP, the only protocol, will configure at EGP type, and it will be worked in two different autonomous systems. If we are configuring BGP protocol, it doesn't means we can use as this protocol as different autonomous systems. Means, what does it mean? We can use this protocol in between two organizations. In between two organizations, we can use this protocol. Means, if you, for example, this is a different organization and this is a different organization, there we have the multiple prefixes like LAN prefixes. They are coming, and these all are the LAN prefixes, different VLANs, and these are the different organization. This is a different enterprise network through ISP. Through ISP, we can communicate to different. This is the IBM, you can assume, and this one is the Wipro. And Wipro having different AS number, that is like 650000 something, and 65,000, and this one is like 65,000 something, 65,100. Okay, likewise, and between ISP we can communicate. This is the protocol only. It will be worked EGP. It is exterior gateway protocol. For example, this is IBM only and different location. And if enterprise to enterprise, our enterprise to our enterprise also, if we want to communicate through ISP, we need a BGP protocol. So without BGP, we cannot reach our different branches at different location. Those branches are a different location. We must use the BGP. Without BGP, it won't possible. So here we'll use IGP protocols. IGP protocol LAN at LAN location, and in this LAN location also we'll use. Now in this case we have a company A. We are working in IBM in also, that is with different location also IBM. We have, if we want to communicate IBM to IBM, our IBM network to IBM network, so we need a BGP protocol. In this case we are using 65,100 here also, likewise 65,100. and 65,100. Here we are using and same thing. This is a AS number actually. AS number 65,000 and AS number is 65. I will discuss what is AS number. Just keep on hold. Now understood where we'll use EGP protocol. Basically, EGP protocol will work in between two our branches with a different location. Otherwise, in between two different organization, in between two ISPs, the IGP will work. BGP will work. BGP stands for Border Gateway Protocol. And now discuss about some brief about the AS number. So AS number basically who will provide it? The AS number provider is INA, Internet Service Authority. They will provide to us the AS numbers and AS numbers from 0 to 1 to 65535. This is the range actually. In this range, the regional internet registry they will provide to us. In INA, we have some organization that is RIR. So they'll actually manage AS numbers in between up to here. But see, 64,512 to 65,535. This is the range. These are all are the private use. It means these all are the free of cost. In like these all are the private IP addresses. How we are getting the private IP addresses at our free of cost. Class A we have range 9200, class B we have the range 172, and class A we have the range that is 10. Likewise, we have here the private range is, this is the private range. In between we can use free of cost, no need to pay. Now move to the how it will be select the best path with the help of basically BGP. Actually, Border Gateway Protocol is a path vector routing protocol. BGP is a path vector routing protocol. What does that mean? How it will be calculate the best path? How it will be calculate the best path based on the path vectors. We have the different paths. So AS origin and local preference. So different path vectors we have. Based on that, it will be calculate the best path. Now tell me, in IGP we have a RIP for path. Some RIP metric is, it's a metric. Like in IGP we have a metric. Those are the hope count is a maximum. Least hope is best for RIP part. Least hope is best in RIP protocol. Least is best in RIP. And we have a formula for eIGRP apart from that OSPF. eIGRP uses the K values. In K values, it will be used bandwidth, load, delay, empty usage. It will be used in eIGRP. But in OSPF, they'll use, in OSPF, it will be used reference bandwidth by interface bandwidth. It will be used the formula. But here we have the path vectors. It will be, it's a path vector routing protocol. Here we have the attributes for best path selection part. Path attributes we have in that weight, local preference. So this kind of multiple path vectors we have. Anyway, we'll discuss. It will be calculated based on the path vectors for best path selection part. And actually, RIP is a layer 7 protocol. And which one is the layer 7 apart from that RIP? RIP is a layer 7 protocol. And as well as RIP also, it is a layer 7 protocol. And BGP also layer 7 protocol. Apart from that, we have a layer 3 protocols, L3 protocols, and L3 protocols. Those are the eIGRP and OSPF. These two protocols are layer 3.
Layer 3.
And they'll use 88 protocol number. For this 88 protocol number, it will be used, and it will be used a 89. And here RIP will use a UDP port number. UDP port number.
520.
Sorry?
520.
520. And here same likewise it will be used. BGP will use one is the protocol, that is TCP. It will be used TCP protocol number. It will be used TCP port number, that is 179. These all are the for identification of service. These all are the identification for the services. And for layer 4 identification, these things it will be used, and layer 4 identification part, it will be used these things. And this is the layer 7 protocols, and these are the layer 3 protocols for identification of service. And basically BGP is a reliable protocol. Because of why it is reliable protocol? It uses TCP port number. So it is unreliable protocol. RIP is unreliable protocol. RIP is a unreliable protocol, but BGP, it is a reliable protocol because of it will be used again three-way handshake. It won't use three-way handshake because it is unreliable protocol. Got it? And whenever so here we have two routers, we enable in between RIP. So it will be sent periodically every 30 seconds neighbor update. You are the alive or not. Router 1 is sending to router 2. My neighbor is alive or not. It will be sent every 30 seconds periodically update. Keep alive messages. It will be sent every 30 seconds. Periodically, it will be sent the neighborship alive or not. If neighbor is not alive, it will be wait for 180 seconds. It will be flash the routing table. At 240 seconds, it will be flash entire routing table. Now move to the BGP part. In BGP neighborship, we enable both the end BGP. So BGP also same, it will be sent every 60 seconds, keep alive messages. Here keep alive messages, every 60 seconds it will be sent. Keep alive messages, neighbor is alive or not. And whenever the neighbor is establishing, it will be used three-way handshake. First, it will be send the sync packet, and neighbor will give the sync plus ACK, sync plus ACK, ACK, and neighbor will be give the acknowledgement. Likewise, three-way handshake, it will be used. That is a reliable protocol. But in RIP part, it is unreliable protocol, it won't wait. It will be sending the keep alive message. Keep only periodically it will be sent 30 seconds, every 30 seconds. That is the reason. This is the major difference. This is the content, you can write it. And it uses TCP protocol with the port number 179 as we discussed. At layer 4 it will be work. So this is a port numbers where it will work basically in layer 4 for identification part it will be used, and it is reliable protocol because of it uses the TCP protocol. And by default the maximum path is 1 only. So why this is 1? So maximum path is here 1 only, but in RIP case maximum path is how much? Max path is
15.
16. Max is 16th hope. Max is 16th hope. If 16th hope is there, it won't reachable.
So in that case, 15 will be the max, right?
You can assume, but when you are calculating from your source, so for example, this is your source, and here you are originated some traffic, and for this is the first hope, and second, third, 4, 5, 6, 7. This is the 15th one. Okay, up to this 15th hope it will be reached. If it is 16th hope, it won't reach. So maximum path is 15, you can say, but 16th hope is there, it won't reach.
Okay.
Got it?
Yes, Salim.
And basically RIP is classful protocol, but eIGRP and OSPF, apart from that we have BGP. These all are the classless routing protocol. These all are the classless routing protocol. What does it mean, classless routing protocol? It will
Classful will
carry,
not carry subnet addresses, and classless will carry subnet address.
yes, subnet mask. It will be carry subnet mask. With carry subnet mask. These all are in OSPF, eIGRP, and BGP. These all are the classless routing protocols. It will be carrying with subnet mask. And here we have a two types of neighborship actually. In BGP, we have a two types of neighborship. One is IGP and one is eGP. Two types of neighborship. And for each neighborship, they'll use different AD values. For internal, it will be used the prefix, the AD value is 200, and this is the AD value, and external prefixes, it will be used AD value that is 200. The AD value is 20 for external and 200 for internal. So we have a two types of BGP neighborship here. One is iBGP, and we have eBGP. So we'll discuss now what is IGP and what is EGP. Two types of neighbor. These are the not a two versions are two types of BGP protocols. This is the not a two types of BGP protocols. This is the neighborship only. It's a neighborship. Don't confuse it. This is not a type of BGP. It is a type of neighborship. So basically, what is AS number? We discussed earlier. Now here, if I am using AS number is 100, and here also if I am using AS number is 100. So in between, I establish a neighborship. So here we have a LAN prefixes again. Here we have a multiple LAN prefixes. So I have advertised this LAN prefixes in this BGP neighbor. And here I have some LAN prefixes. I'll advertise this all the prefixes, some hundreds of lakhs of prefixes. So lakhs of VLANs I have. So lakhs of users or lakhs, thousands of VLAN I have. Thousands of VLANs I have. I'll advertise these VLANs in BGP in this neighborship, and I'll advertise in this VLANs in this BGP. So this is the neighborship which we call it is a iBGP, internal BGP. So say whenever you will see the same AS number, that neighborship we call it as a iBGP, internal BGP. That will be used AD value, that is 200. Now move to the, if you see here in between neighborship, here we are using AD values again 100, and if I am using here AD values 200. So this BGP we call it as, here I'll advertise some prefixes, LAN prefixes, and here I'll advertise same LAN prefixes. So this BGP, whenever you'll see two different AS number, that neighborship we call it as a eBGP, exterior gateway protocol, exterior border gateway protocol. This one is use the AD value, that is 20, and AD is 20 here, and here AD is 200. Administrative distance. So whenever you will see internal BGP, that is AD value is 200, and external BGP uses the AD value is 20. It's interview question. Got it?
Yes, Salim.
And in case of BGP protocol, routers send all the unicast messages towards each other, because there is no concept of, actually here we don't have concept of multicast IP address. So here we are, whichever the neighborship also establishing directly connected only. So indirectly connected also we have the neighborship, even though, but in this neighbors, they are sending the messages with unicast only. Here we don't have concept that is multicast IP address. So now tell me, RIP version 2 multicast IP address is RIP version 2, and RIP version 1 is broadcast. It will be do the broadcast information, that is 255, 255, 255 only. And this is a RIP version 1.
So for the version 2, it is 240, 224.0.0.
224 dot
0.0.0.
sure. And what about EIGRP? And what about the OSPF? For neighborship, how they will send the updates. RIP part, it will be send the update. Here we don't have any multicast concept. It will be sent all the unicast messages only. Now tell me, for this, which which multicast IP address it will be used, and RIP OSPF part, what are the multicast IP addresses? They'll
For
send.
OSPF, it's 224.0.0.5 and .6.
Okay.
For eIGRP, it is 224.0.0.10
Okay.
and .9 for RIP.
So here it will be used DR and BDR routers. BDR routers.
Yes. For the designated
And
router,
this
it's
all the routers, DR other routers. So, but here we don't have any concept of like multicast IP addresses. It will be sent unicast messages only. And BGP doesn't support the concept of dynamic neighborship. As we discussed, BGP, it will be doesn't support the dynamic neighborship. Here we don't have dynamic neighborship concept. So how will enable the in between two? This is a router 1 and router 2. If I want to enable, so here I'll use AS number again 100, and here also AS number is 100. So this 2 is which BGP neighborship will establish? These are two neighbors, same AS. So which BGP neighborship they will establish?
iBGP,
Yes, IBGP. The piece IBGP.
internal.
Yeah, internal BGP, internal border gateway protocol neighborship will establish. So because of same AS. So whenever I'll use likewise, so statically, manually, I will tell like my neighbor is R1. I'll inform to router 1, yeah, my neighbor is R1. How manually I'm assigning the my neighbor. So that is the reason it won't support. Here we don't have concept type dynamic neighborship. So how will, so here my IP address is like 11.1.1.2, and this is my IP address is fast Ethernet 0/0, FS 0/0, F 0/0, and here F 0/1, you can have F 0/1, and IP address is here 11.1.1.1. So once I'll enable with the help of router command, router and BGP, and I'll give the AS number. Where in global configuration mode in R1. So in config mode, I'll give likewise. Once I'll enable the routing protocol, that is BGP AS number is 200. After then I'll move to the, I'll enter to router. This I will be sure. And here I'll give my neighbor. Manually I'll define, I'll tell likewise my neighbor is, who is my neighbor? 11.1.1.2, and my remote is remote AS, remote autonomous system number is 11.1.1.2. So here manually I'll inform to this router R1, my neighbor is like this. This is AS number, that is 100. If this is a different AS, if you can assume this is the AS number is 200, so it is eBGP, then likewise I'll configure manually. This is how the configuration will be work. Manually, we have to define the neighborship. Statically, we'll have to define our neighborship in between routers. Then only neighborship will be formed. So statically, I have to enable the neighborship in between two neighbors. Only statically. It won't work in dynamic neighborship. It don't form. But in OSPF, only with will enable router BGP out of router OSPF. After then just we give some process ID. After then we advertise some network with network command 11.1.1.0. After then wildcard must 0.0.255 and area is 0. Like we advertise area is 0. Then it will work. Dynamically it will form the neighborship in between routers. But here we have to manually define we have to statically define the neighborship. Then only neighborship will be formed. That is what eBGP. That is the reason it have maximum path only 1. That is the reason it will be have maximum path is 1. So even though if it is directly connected, apart from that, indirect neighborship also we can form. What is indirect neighborship? 1, 2, 3. So this is my neighbor and this is my neighbor. If I want to enable from R1 to R2, this is a R3. In between R2 also we have. I'll configure likewise also without without entry anything of this router also. I'll not configure anything BGP related, but I'll configure BGP neighborship in between two routers also. That is indirect neighborship. Indirect neighborship also we can enable. Direct neighborship also, indirect neighborship also we can enable. That is possible with the help of BGP. That is with the help of loopback IP addresses will enable. Loopback IP address. Everyone know what is loopback IP addresses. This is a virtual interfaces. So in between for reachability is required. For reachability part, we will use IGP, any IGP protocol. RIP or OSPF or OSPF eHRP. Any IGP protocol is required for reachability. For this router to this router, reachability is mandatory. After then only you can establish the neighborship, that is indirect BGP neighborship. Indirect BGP neighborship. Here we can enable direct neighborship with the connected interfaces, but here we can enable the indirect neighborship with unconnected neighbors also. Unconnected means they are not connected to each other. That kind of neighborship also possible, but reachability is required with IGP. With RIP protocol or any protocol, we can establish the reachability for R1 to R2. Once ping is enabled, ping is done, then R1 to R2, the ping is done. Just you can use these commands, then it will be neighborship will be formed. That is, we call it as a indirect neighborship. And the reason behind BGP, it will be used the lacks of prefixes. In routing table, we have the main reason of BGP. Why we need BGP? We have a IGP protocols also. So the reason behind BGP is it will be maintain the lacks of prefixes. So IGP protocols, it won't maintain lakhs of, it will be maintain only thousands of prefixes only. But BGP will maintain lakhs of prefixes inside BGP routing table. So mostly at our core routers only, core devices, edge devices only will use BGP protocol. Apart from that, in our organization, at our in so how the network type, this is the edge customer edge router, and this is a customer edge router, and here we have a core switch, and core switch is connected to again some distribution switches, and this is the distribution switches. Distribution switches again connected to access switches. This is a network hierarchy, and this is a access switches. These all are the access switches, and these all are the access switches. Access switches, and access switches connected some multiple users. These all are the users. User or server or anything you can assume. Landline, mobile, IP phones. So these all are the users. Host. These all are the host. So up to here we'll use IGP protocol. IGP protocol, and here in between we'll use, this is a customer edge again, and this is the ISP you can assume, and in between we'll use, this is BGP will use here, and IGP2 will redistribute these prefixes, redistribute this all the IGP. If you are using here OSPF, will redistribute from OSPF to BGP protocol. Then only it will be possible. This likewise, this is a network hierarchy design. Likewise, same thing here also. And X core switch, and core switch is connected to distribution, and distribution is connected to again access switches. Likewise, this is, here we'll use IGP protocol. This is internal gateway protocols, and external gateway protocols will use in between the two branches with ISP connected. Got it? The hierarchical design likewise will use BGP. This is all about the basic of BGP. Do you have any questions? And apart from that, where we'll use mostly BGP protocol, the concept is where we'll use in this BGP. BGP can maintain lakhs of prefixes inside the BGP routing table. Yes, it will be maintain lakhs of prefixes, lakhs of networks, lakhs of VLAN, you can assume lakhs of user information. And we use this concept in enterprise networks. Yes, if we have a big size of enterprise network, then we'll use. And on ISP routers we'll use. If you are in working in ISP, then we'll use the BGP protocol, internet service provider, and to make communication possible between two ISPs, two different ISPs. So this is one location to another location. So assume this is Hyderabad location, and this one is the Delhi location. So in between multiple ISPs because only if one ISP don't possible to give the connectivity between two different locations, two different metro city locations. So we need different ISPs in between. Between different ISP we need. This is Geo, you can assume. and Airtel Bharati and BSNL likewise. So in between different ISPs we work. And if you are in USA, so it now you tell me it won't work, right? That is the reason we need a BGP protocol to communicate two different ISPs. So here we have some customer types also, types of customers also in BGP. So I'll give the overview of customer types. So which kind of customers they'll use a BGP protocol, which kind of customers they no need for BGP routing protocol. So if it is single home type, and we have a 4 types here. First one is single home, and second one is dual home customer type, and third one is here we have a single multi-homed customer type, and fourth one we have here dual multi-homed customer type. Now first we'll discuss what is single homed customer type. One is ISP, single homed customer type, and ISP is connected one router, that is core router, edge router, and edge router having some LAN prefixes. Here we have multiple LAN prefixes. These all are the LAN prefixes. Here we are using the LAN prefixes, and in between we connected one interface. So in this case, in single homed customer case, if I am using the BGP protocol, so here we have to use eBGP actually. So this is the single homed customer type. And if I'll not use also, no issue. If I am using here default route, IP route, so mostly they'll use here in this case, we no need for BGP also. IP route, default route. If LAN prefixes I want to reach Google something, so I'll use default route whenever that unknown destination. Mostly we'll use likewise only. That is, we call it as a single homed customer type. This is a single homed customer type. This is a single homed customer type. Now move to the dual homed customer type. Here we have a again ISP, and ISP is connected network, and this network core edge router connected with multiple LAN prefixes. But here it will use dual network. If here this ISP is goes down, then we cannot reach to our Google. We cannot reach ISP. If we are using single homed customer, you can use eBGP. Apart from that, we have a IP route, default route also. With the default route also, we can use this single homed. But if this ISP is goes down, we cannot reach. So we have a concept like here dual homed customer type. In real time, they'll use likewise only. This is dual homed customer type. If one link keys goes down also, we have a redundancy path. We can reach to internet with this path. This is, we call it as a dual homed. Now move to the single multi-homed. I'll clear this. Now move to the single multi-homed customer type. So
They will use multiple ISPs.
yes, there will use multiple ISPs. Only one router, one core router, and this core router is connected again. This is ISP1 and ISP2, Geo ISP and Airtel Bharati ISP, you can assume. This is a Geo ISP1 and 1 and this is a 2. If one part is goes down, also we have another ISP. If this ISP is goes down, so we cannot able to reach internet. If entire ISP will sometime ISP also will goes down, right? So that time we cannot reach to internet. So that is the reason we have a single multi-homed customer type. Here we'll use BGP. And now move to the dual multi-homed customer type. So dual multi-homed customer type means in mostly data center, this kind of setup will be happen. This is a branch setup likewise. This is the communicate. The network will be entire thing will be processed. Likewise, they are again LAN prefixes. And here we have a LAN prefixes. For here we'll use like HSRP some protocols. If we are using like core switch is like if this is a your core switch in between. So here we'll use HSRP concept, FHRP, that is FHRP, first hop redundancy protocol. First hop redundancy. Here we have some types, that is VRRP, and second type is HSRP, and third type is GLBP. Next concept we'll discuss these things. And the virtual gateway we'll use for this. Likewise, we have a switches or end users will use likewise. This is a switch. Switch is connected to host. This host part will use some virtual gateways. So here in between we'll use eBGP, exterior gateway protocol, in real time. This concept mostly in organizations will use, and this is the concept. This is a big size of organization will use. This is a data center setup also, you can assume, and this is a branch setup. In branch networks, likewise. In data centers, likewise. Here you can use HSRP also, no issue. If one ISP goes down, also we have a redundancy path. Here also we'll use FHRP concept. If one path goes down, also we have a different path. If this ISP goes down, also we have another ISP for this router reachability, also this router also. If this ISP goes down, also we have another path. If this ISP goes down, also we have a different path. Likewise, this is a customer type actually. In customer types, any doubts in this?
No, Arif.
Good. And two types of neighborship, IGP and iBGP and eBGP we discussed, and here we have some message types. Some message types in BGP we have. First is here open message and keep alive message. Second one is keep alive message. And third one is update message. And fourth one is notification message. Route refresh message. These are the message types. We'll discuss it one by one. So types of messages: open message, keep alive message, update message, notification message, route refresh message. So once we enable the with some, for example, here we are using AS number 100 and AS number 200. So this BGP is eBGP. Actually neighborship is eBGP neighborship we established. So first, whenever the neighborship message is sent, so that is first it will be sent with the port number TCP with port number 179. It will be sent one message, that is you are the my neighbor. That is, we call it as a open message. Like in OSPF, we have a messages, right? Hello, DBD, LS request, LS acknowledgement. Before that, LSR, LSU update, LS update, and LS acknowledgement. Likewise, hello message, what it will be work, establishing the neighborship in between. So before that, establishing the neighborship, it will be BGP is reliable protocols. That is the reason it will be used three-way handshake. So first it will be send the sync packet with the port number is 179. It will be give the acknowledgement with a port number, different port number, random port number. It will be used any random port number, any TCP random port number, that is 1024 something. It will be used. So after then it will be give the acknowledgement. So this is a session. One session is generated. This session up to neighborship, how much time it will be established, up to that this session will be happen. In session layer, we have a session, right? And likewise, session will be established. TCP session, that is reliable session, neighborship session. So the neighborship session is alive or not, it will be sent every 60 second. Every 60 second, it will be send the messages. My neighbor, you are alive or not? That is keep alive messages. It will be sent keep alive messages. Both our neighbors are established. Both neighbors are established. This is having 100 prefixes and this having 100 prefixes. R2 having 100 prefixes and R1 having 100 prefixes. With the update message, they will send entire routing table, entire prefixes information. Once the neighborship open message is sent, neighborship is formed, it will be send keep alive messages every 60 seconds. After then, the neighborship is formed, then it will be send entire routing table, entire prefixes information with update message. If neighborship is goes down, if neighborship is faulty, then notification message will be happen. So first it will be sent open message for neighborship is forming is kind of hello or hello message. And once neighborship is established, it will be sent every 60 seconds. Keep allowing messages. If neighborship is went down, this neighborship is goes down, then it will be wait up to 180 seconds. That is hold down timer. 3 times of this into 3 times of this wait. It will be wait for 180 seconds. If neighbor is not alive, again neighbor is not came up, then it will be break the neighborship. It will break the neighborship. That is hold down timer. So hello timer is here 60 seconds and hold down timer is hold means dead timer. Hold timer is 180 seconds. So if neighborship is goes down, then it will be getting a notification message that is neighborship is faulty. The reason behind it will be sent with the basis of notification. If any reason happen, it will be sent in that notification message. Because of this is the reason because of this interface is goes down. That is the reason BGP neighborship is went down. It will be sent the message, that is notification message. And route refresh. Route refresh means whenever we are doing the hard reset, that time route refresh message will be generated. Hard reset means reload something. These all are the message types. Understood, everyone? So in BGP, we have a 3 types of table. And OSPF also we have a 3 types of table, like neighbor table, routing table, OSPF routing table, and neighborship table. Neighbor table, OSPF routing table, OSPF database table. And here we have a BGP table, BGP table, BGP routing table, and BGP neighbor table, and here we have a BGP routing table also. Routing table. One more is global routing table. Routing table, we can check the entire routes information. Same. And BGP table for will use the command. Here we'll use the command show IP BGP. Show IP BGP. We'll use this command. For BGP neighborship part, we'll use here show IP BGP summary. Summary or will use, and we'll use some summary command. Apart from that, we'll use neighborship command also. Summary command, and we'll use show BGP, show IP BGP, and we'll use neighbor command also. And global routing table part, same. So IP route, we'll use this command. These are 3 tables BGP will maintain. In these 3 tables, we can verify it. Apart from that, we have a troubleshoot commands we'll discuss in when we'll do the labs. And for establishing neighborship, they'll use some states. BGP states we have. Here we have 6 states. Ideal state, connect state, active state, open send, open confirm, and establish. So in between, we configured. Here we'll use AS number is 100 and AS number is 200. Here the one router we enable the neighbor with neighbor command. So here we enable with neighbor command. Here we haven't configured any BGP neighbor. We have not configured anything BGP related. But here we configured BGP. So that is ideal message. That is down state actually. And once they enable the neighborship, then it will be moved to the connect state. If anything problem, active state. Active, it means the neighborship is not established in between. The active means the neighborship is not enabled. So open send means they are once the neighborship is formed, they will send entire routing information with open send and open confirm. In these states they will send. And establish means the neighborship is established in between 2 neighbors. In between 2 neighbors, the neighborship is established. That is established state. Active means here no neighborship is formed. If anything problem in between the 2 routers, then it will be moved to the active state. active, whenever you will see the active state of BGP, the neighborship is not formed. I'll show you in lab this thing, states part. Do you have any questions up to here? Shall we move to the lab?
Yes, sir. We can.
Apart from that, we have a path attributes, path selection part. We have some prefix attributes here. So I'll give you the overview. So these all are the path attributes. Based on this path attribute only, it will be select the best path from one. If we have like multiple routers, we connected. So here my source and my destination. So it basically having only one path, even though. So in between we have a multiple routers. That time it will be check the next hop reachability, and it will be check the weight, local preference, self advertised, AS path, origin code, and mid. It's symmetric and external, internal, external over internal, and IGP cost to reach, and oldest path, and lowest neighbor router ID, and lowest neighbor IP address. These all are the path attributes. Based on these path attributes, it will be select the best path from R1 to R2. This is the overview only this. Okay, now we'll move to the lab. This is the entire thing of BGP protocol.